My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. In this lecture, we will try to understand new SVM, control errors and support vectors. The standard support vector machine formulation with C as our hyperparameter is called CSVM, of course C soft SVM. CSVM original formulation, in this formulation remember C is greater than or equal to 0. There is an alternative formulation of support vector machines is called new SVM. Our hyperparameter is new. This hyperparameter lies between 0 and 1. Just observe this one. This hyperparameter is in between 0 and 1. Here in the case of CSVM, your hyperparameter is greater than or equal to 0. This what about C? It is hard to interpret. Why? Because it's C greater than or equal to 0. But here for new, you have nice interpretation. What is interpretation? You have nice interpretation. Of course, it is lies in between 0 and 1. And the one good thing is, let me show that relation. What is this? New is greater than or equal to fraction of errors. Isn't it? New, I can say, what does it mean? This new is an upper bound. I can say this new is upper bound on fraction of errors. This point is very important. There is another important point is new is less than or equal to what is this? Fraction of support vectors. And new, what is this new? I can say new is lower bound. It is lower bound on fraction of support vectors, isn't it? Suppose I want to build SVM with training data. Let me say I want to build SVM with the training data dtrain. Suppose I don't want to make more than 10% of errors. Just I set new equal to 10%. Just see, new equal to 10% in 0.01. If I want less than 1% errors, I must set new equal to 0.01. Even though new is a hyperparameter that we can find using grid search cross validation, I can fix new now. In new SVM formulation, new is maximum number of errors that can happen. Just see, new is maximum number of errors. Isn't it? Maximum, that is upper bound, isn't it? Similarly, new is lower bound on the fraction of support vectors. This point is important, that's why I am repeating. Just say, let me assume new equal to 0.01. So, what does it mean? This mean that fraction of errors or percentage of errors is almost 1%. And the number of support vectors is greater than or equal to 1%. What is this? Number of support vectors is greater than or equal to 1% of endpoints. So, in a way, what is this relation indicates? It is controlling this particular equation. I am repeating this particular inequality. It is controlling the number of errors. But for runtime complexity, we want fewer and fewer support vectors. Unfortunately, just say this relation. Unfortunately, new SVM new SVM controls the errors. Just see, let me repeat, new SVM controls the errors but does not controls the errors and does not control support vectors. Just see this one. Does not control support vectors. I will repeat. Unfortunately, new SVM controls the errors. Just see. It is upper bound. Controls the errors. But does not control. Just see this relation. Does not control support vectors. Why? Because for runtime complexity, we want fewer and fewer support vectors. Unfortunately, new SVM controls the errors and does not control the support vectors. Number of support vectors are greater than or equal to, just see, number of support vectors is greater than, relation is greater than or equal to errors. What about errors? Number of errors are less than or equal to, isn't it? That relation we must understand. Otherwise, let me take one simple example. If I set my new equal to 0.01, I know this guarantees my error less than 1% and number of support vectors is greater than or equal to 1% of n. Let me assume, otherwise, let n equal to 100,000. Let it be. And what is number of support vectors? Number of support vectors is equal to k, that is as new equal 0.01. This is 0.01% of n means what? This k will be, you will get 1000, isn't it? At least 1000. It could be greater than 1000 also. K could be greater than 1000. At least 1000 support vectors. So new SVM is one way for us to get understanding of how many support vectors we get. How many support vectors means at least in this case 1000 support vectors and number of misclassified points in the training data. Proving CSVM, proving, let me rewrite otherwise, proving CSVM and new SVM are equivalent. Actually, they are equivalent. Is a research paper. Research paper, isn't it? New has a nice interpretation. It is upper bound on number of errors and lower bound on number of support vectors. Of course, we cannot control number of support vectors with new SVM. Just go through this lecture, and if you have any difficulty, please keep a comment. This lecture is very important. Thank you very much.